Turn it so that you are visible fully.
Good morning, one and all. Today we have with us a very popular resource person who is an authority in Indian astronomy, Dr. S Balachandra Rao. I'm happy to introduce today's resource person for this webinar session. Dr. Balachandra Rao is Honorary Director at Bharatiya Vidya Bhavan Gandhi Center of Science and Human Values, Bengaluru. He retired as a Principal and Professor of Mathematics from National College, Bengaluru after 35 years of service of teaching undergraduate, postgraduate students and guiding PhD candidates. Dr. Rao is Honorary Professor at the National Institute of Advanced Studies, NIAS, and former member of Research Council of India National Commission of History of Science. Dr. Rao is also a former member of Editorial Board of Indian Journal of History of Science, INSA. Currently, he is a member of National Commission for History of Science, New Delhi. Dr. Rao has been working on research projects in Indian astronomy under Indian National Science Academy, New Delhi since 1993. Among the various books authored by Dr. Balachandra Rao, the popular ones are Indian Mathematics and Astronomy, Some Landmarks, revised 3rd edition, about Ancient Indian Astronomy, Planetary Positions and Eclipses with Programs, BRPC, Delhi, Aryabhatta 1 and his Astronomy, Bhaskara 1 and his Astronomy, both from RSVP Tirupati, Indian Astronomy, a primer, Eclipses in Indian Astronomy, Transits and Occultations in Indian Astronomy, published by Bhavan's Gandhi Center. Recently, Dr. Rao's English expositions with mathematical notes of famous Sanskrit astronomical texts, Rahalagvam of Ganesha Daivagnya and Karana Kutuhalam of Bhaskara II, authored jointly with Dr. S.K. Uma, has been published by INSA, New Delhi. Dr. Rao presented an invited paper on Copernicus, Nilakanta Somayaji and of 13th World Sanskrit Conference held at Edinburgh, Scotland in July 2006. In the recent volume, Science in India, edited by Professor Jayant Nalikar, Dr. Rao's 2 articles have appeared, Origins of Indian Astrology, Grahalagavam, Special Features and Efficacy of Procedures, jointly with Dr. S.K. Uma and Dr. Padmaja Venugopal. Besides nearly 20 books in Kannada on mathematics and astronomy, the latest addition to the list of his publication is Indian Astronomy, Concepts and Procedures. Currently, he is a member of International Astronomical Union, IAU, with the headquarters in Paris. Now over to Dr. S. Balachandra Rao, sir.
Good morning to you all, friends. I'm happy to be the first speaker of the series of talks. And in this presentation, I shall briefly be presenting before you some of the glimpses of India's contribution to mathematics during ancient and medieval periods. Of course, emerging trends in modern mathematics, while we speak on that or become familiar with such a contribution, we should also know how right from the roots this subject has developed. Without the knowledge of roots and its the development of the subject in later centuries, we can't do enough justice to the modern developments in the subject. And that is the reason why I'm trying to take you back to the roots of the mathematical contribution of our own country, with which every one of us should really become familiar. As is customary, I'll start with the well-known shloka from the earliest Indian astronomical text in Sanskrit called Vedanga Jyotisha. The shloka I'm quoting is as follows. I'll first read the translation, then read the Sanskrit shloka for the benefit of those who love Sanskrit. Like the crests on the heads of the peacocks, like the gems on the hoods of the cobras, astronomy or mathematics is at the top of Vedanga Shastras the auxiliary branches of the Vedic knowledge. That's what the shloka says. In Sanskrit, it reads, Yatashika Mayuranam. That means like the crests on the heads of the peacocks. Naganam Manayo Yata. Like the imaginary gem in the hoods of the cobras. Tadvat, like that. Vedanga Shastranam. Among the Vedanga Shastras, auxiliaries of the Vedic body, Jyotisham, that is astronomy, or Ganitam, that is mathematics, Murdhanistitam is at the top. Here I have a line of explanation for the word Jyotisham. In the modern parlance, Jyotisham is unfortunately interpreted to mean the predictive astrology, planetary astrology. But actually, when this word was used in the past, it did not mean astrology at all. By Jyotisham, they meant astronomy only, and particularly they were interested in calendrical astronomy because for day-to-day dealings, as also for religious performances, they needed calendrical system. So that calendrical system, as in other cultures also, is dependent on the motion of particularly the sun and the moon as observed from the earth. So that's how astronomy developed partially, though natural curiosity to study the phenomena in the sky motivated the knowledge of astronomy, not only in our culture, but also in other ancient cultures like Babylonian, Egyptian, Chinese, and so on. Here is a list of our top mathematicians and astronomers who contributed to this field since Aryabhata. Before Aryabhata also, there was tremendous development in the subject, but we don't have much recording of all that. In fact, the first shloka I quoted is from Vedanga Jyotisha, which is supposed to be the earliest available Sanskrit text on astronomy. It does not contain anything related to astrology, but for calendrical system, whatever was necessary is given in the text of Vedanga Jyotisha. And historians assign that text to around 1200 BC. And after that, up to the period of Aryabhata in the 5th century, we don't really know how much development took place in the country, but definitely substantial contribution was there. And the main contribution is the numeral system. The numeral system followed the world over today, we are proud to say, is our India's contribution. Not only the 10-based place value system of the numerical symbolism, but even the symbols used, which we are using today, 1 to 9 and 0, they are virtually contribution of India. Nasik inscription, and then another inscription at Gwalior, they prove that it is India which has given to the world the 10 symbols by which all numbers, huge and small, can be represented. And this is complemented by none less than Laplace, the famous French mathematician and physicist. Okay, I told you that from Aryabhata onwards, we know definitely the development of the subject, both astronomy and mathematics in this country. And their texts are also mostly available. Here is a list of these top astronomers and mathematicians, starting with Aryabhata. He was in the 5th century, born in 476. His texts are Aryabhatiyam and another text called Arya Siddhanta, but the text is not available now. We know about the text from the quotations in the later text from the original one, which is not available. But Aryabhatiyam is available, and every student of mathematics and astronomy, at least in our country, should be familiar with this text. And in English translation, as also Hindi translation, have been published by Indian National Science Academy, Delhi. And I'm proud to say a Kannada translation is also brought out by us, published from Bharati Vidya Bhavan, Bangalore. Then we had his junior contemporary, Varahamihira. Somehow, Varahamihira is more popular perhaps than Aryabhata. I don't go into details, Varamira's astronomical text, Panchasiddhantika, is famous. Then he wrote an encyclopedic text called Brihat Samhita. That's really a huge text, as the adjective Brihat means. Well, it accommodates sciences like Haya Shastra, Gaja Shastra, Ratna Shastra, and then so many things, geography, Ayurveda, music, and mathematics and astronomy also. That way it is truly encyclopedic. He wrote an astrological text also called Brihad Jatakam. For those who practice astrology in this country, this Brihad Jatakam is like the Bible. Well, then we had the great astronomer and mathematician Bhaskara I. We designate this Bhaskara as Bhaskara I because there were two Bhaskaracharyas, this Bhaskara I of the 7th century and Bhaskara II, who is more popular, belonging to the 12th century. Bhaskara I plays a very significant role in the history of Indian mathematics and astronomy because it is due to his commentary called Aryabhatiya Bhashya and also two independent texts he composed, Mahabhaskariyam and Lagubhaskariyam, that we have been able to understand Aryabhata's system of mathematics and astronomy. Aryabhatiyam itself is too brief. So if studied independently, one can't easily follow the procedures of Aryabhata because it was not meant to be an elaborate text. But Bhaskara I has written an exhaustive commentary, though it's not fully complete, and also two independent texts, Mahabhaskariya and Lagubhaskariya, which clearly explain the procedures of Aryabhata. Brahmagupta is also of the same century. He was a contemporary of Bhaskara I, and Brahmagupta is considered our mathematician par excellence. I will be referring to Brahmagupta now and then in course of my discussion. And his Brahmasputa Siddhanta is a voluminous text on astronomy. In that, two chapters are dedicated to pure mathematics. One is on arithmetic, the other is on algebra. Arithmetic is called Vyakta Ganita, and the second one, algebra, is called Avyakta Ganita. And remarkable contribution of Brahmagupta can be seen in those two chapters to mathematics. The rest of the chapters are devoted to astronomy proper. Then we had another series of mathematicians, Vateshwara in the 9th century. But the more famous one, or who is more important for us, is Manjulacharya of the 10th century. This Manjulacharya is important, I will tell you why. His composition is, which is available to us now, is called Lagumanasam, which is a brief handbook on astronomy. But why he is important is, he is one of the earliest to give the glimpses of calculus. We are all told by our teachers and textbooks that calculus was invented by Newton in Britain and by Leibniz in Germany in the 17th century. Yes, both of them were extraordinarily great mathematicians and physicists and astronomers. So calculus invention, that credit goes to them, that is right. But before them, glimpses of calculus can be gleaned in our own Indian text. And in the 10th century, in the year 932, this handbook called Lagumanasam was composed by Manjulacharya. In that text, while discussing grahanas, that is eclipses, the author says that for predicting the correct sparsha and moksha, beginning and ending of eclipses, we need to consider the true daily motion of the moon, the instantaneous angular velocity of the moon, which he calls Tatkalika Gati. In Sanskrit, Tatkalika means instantaneous. So not the average angular velocity of the moon. The earlier practice, not only in India, even in Greek astronomy, due to Ptolemy and others, they were considering only the average or the mean daily motion of the moon, namely 13 degrees, 10 minutes. But this man, Manjula, tells us that we have to calculate the true, that is that day's instantaneous angular velocity, only that can guarantee the sparsha and moksha timings. But then the next question is, how do you get the instantaneous angular velocity? Today we use differential calculus and use the differential or the derivative from which it can be obtained. And here Manjula, because calculus had not yet born, he tells us of in terms of differences. He gives a table of differences, and the differences actually are the cosine of the argument there. In other words, he says that in our modern language, the differential of sine function is cosine. That is a very significant contribution of Manjulacharya. Then we have another Aryabhatta called Aryabhatta II. He composed a text called Mahasiddhanta, which is not that popular. But the more popular astronomer and mathematician was Bhaskara II, who belonged to the 12th century. And he is popular maybe because of his elementary text called Lilavati. Lilavati is well known to most of our mathematics people. It's an elementary text on arithmetic, algebra, and geometry. No trigonometry is dealt with. Usually trigonometry is dealt with in astronomical texts, and they were experts in three-dimensional trigonometry, which we call spherical trigonometry. Okay, so far as astronomy is concerned, Bhaskara's two works are famous, Siddhanta Shiromani, which is a voluminous text, and then a handbook called Karana Kutuhalam. And Karana Kutuhalam, we have the pride of mentioning that we have translated that into English with modern explanation notes and all that, and it is published by Indian National Science Academy. Then we had a series of famous Kerala astronomers. See, after Bhaskaracharya, what did happen to mathematics and astronomy in India? The general belief among the early 20th century or late 19th century scholars in India, particularly in Maharashtra and elsewhere, was that no development was possible in India after Bhaskara II, mainly because of historical reasons. Foreign invasions were there, continuous ones, and also natural calamities like drought, etc. were there. And so in the northern belt particularly, no progress was there culturally and also academically. And hence, it is said that after Bhaskara II, there was no development at all. But fortunately, this is not fully true. And we are glad that in South India, particularly in Kerala region, tremendous development took place from the 14th century onwards up to the advent of the British system of education in the 19th century. Till then, in Kerala, a really great and significant contribution took place. And some of them I will mention. In fact, the earliest among the Kerala contributors is Madhava in the 14th century. In fact, Madhava gives us infinite series of sine function and cosine function. Today, we learn those expansions of functions from calculus using the Maclaurin series, Taylor series, and all that. All those developments took place after Newton invented calculus. But here in India, about 3 or 4 centuries before Newton, we see mention of infinite series for sin x and cos x, exactly what we today use. So also for pi by 4. There is a series which we call Gregory series for tan inverse x. So in tan inverse x, if you take x equals 1, it becomes pi by 4. So that series for pi by 4 is precisely what Madhava gave in Kerala around 14th century. And those series are repeated by his followers like Parameshwara and later astronomers. And Madhava's work related to that is currently not available. Many manuscripts are like that lost, unfortunately, and thousands of them still remain unedited. That is the tragedy of this country. Well, Parameshwara was himself a very great astronomer and mathematician. And after Parameshwara, we have Nilakanta Somayaji, who is considered perhaps as the greatest among contributors to astronomy, and his Tantra Sangraha is the monumental work on astronomy. And also he wrote a commentary on Aryabhatiya called Aryabhatiya Bhashya. I may refer to Nilkant Somayaji a bit later in the context of astronomy. And like that, after him, Chitrabhanu and others were Kerala astronomers up to about 19th century. Pudumana Somayaji and all these people were there. They have all significantly contributed. And for a change, we have a Maharashtrian astronomer, Ganesha Devadnya. He was born at Nandigrama in Maharashtra, but he worked from Varanasi. And not only this Ganesha Devadnya, a series of Devadnyas, all from Maharashtra origin. They worked from Varanasi because that was the important center of learning and great recognition and popularity and patronage. All these scholars got in Varanasi those days. So that could be a reason. His text is Grahalagam, which is extremely popular among Indian astronomers, more particularly the Panchanga makers. Then we have another great Kerala astronomer by name Jeshtadeva, around 1540, and he composed a text called Yukti Bhasha. It is called Yukti Bhasha. Bhasha there refers to the local language Malayalam in which it is composed. It's called Yukti because in that text we have rationales or mathematical proofs for the famous results from mathematics and astronomy. For the first time, which we have such a full text of proofs. Otherwise, the charge was that Indians rarely gave proofs. Not that they did not know the proofs for theorems, they knew very well, and they passed on these proofs to their students orally. And because of those days, they had the difficulty of writing. They didn't have paper and all that which we advantage today we have. They had to etch on leaves. All those practical difficulties were there, and to maintain those leaves was also not easy. So they were very brief in their statements, but commentators now and then did give proofs for astronomical and mathematical results. Then again, for a change from these Kerala contributors, we have the famous astronomer from Orissa, and among the participants registered, I hope some are from Orissa also. Be proud of your own astronomer, Chandrasekhara Samanta, and he has written a Sanskrit voluminous text called Siddhanta Darpana. And important thing about this Chandrasekhara Samanta is that his text gives results which are very much comparable to modern results, which are very scientific. And himself, he was not familiar with telescope, though telescope was there, and he was not modern educated at all. And he is considered as the last link of the traditional astronomers. He is considered as barefoot astronomer. And he led a very simple life, though he came from a royal family. And we are proud of his text, Siddhanta Darpana, which has been translated to English as well as Hindi. Then Kerala astronomer Shankara Varman is there. He was in the 19th century. He composed a text called Sadratnamala. Then what is the link between traditional astronomy and modern astronomy? As students of science, we must be familiar with all this. And astronomy is a science. It is a growing science. So it is not just the history of astronomy. History of astronomy is as important as astronomy itself because there is a continuous development. And as a link between traditional astronomy up to 17th or 18th century and our modern astronomy, we have this Maharashtrian astronomer, Venkatesh Ketkar. He was from Bagalkot. Bagalkot is now in our Karnataka, and I'm glad that there are young promising astronomers today from Bagalkot. I hope they take a note of this and will study Venkatesh Ketkar's text, Jyotirganitam. He composed it in 1898, and in 1900 or 1901 or 2, he composed another popular text called Ketakiya Grahaganitam. And there are Panchanga makers today who used this Ketakiya Grahanitam for composing what they called Drugganita Panchanga today also. So Ketkar played a very significant role in linking traditional astronomy with modern astronomy. He used the Newcomb's, Leverrier, Brown formulae for calculating the positions of planets, then phenomena like eclipses, etc. But he put all these expressions of Newcomb and others in the typical Sanskrit Siddhantic style, which only these Panchanga makers could understand. They could not understand your sine squared, cos cubed, and all that, or sine of 3 theta, 4 theta, and all that. So Ketkar did the yeoman service to the subject of putting them in the Siddhantic language or traditional language, which the Sanskrit Panchanga makers could easily understand. That's how his works are popular. I don't go into details of each one of them, but a brief mention I shall try to make. As I mentioned earlier, Bhaskara I of the 7th century contributed to the popularization of Aryabhata's procedures by writing a commentary on that, which unfortunately is not complete because maybe he passed away after composing a couple of chapters. He is supposed to be from the place called Vallabhi, which is in the Saurashtra region, close to modern Gujarat. Bhaskara I mentions his region as Ashmaka, and even Aryabhata is referred to as Ashmakiya. What is this Ashmaka country? There is much controversy about it. Some people believe it refers to Kerala. Why Kerala is a question. One main reason given is that Aryabhata's system of astronomy became popular only in the Kerala region. It's not known why, because Aryabhata belonged to Magadha region. He explicitly mentions that he was from Pataliputra, I mean the modern Patna, Kusumapura, that was the ancient name given to that place. And he himself mentions that his system had become popular in Kusumapura. Kusumapura has got its own history. It was center of learning of Jain scholars. Incidentally, the ancient contribution to mathematics prior to Aryabhata was mainly by Jains. So, and their texts generally were in Prakrit languages and not in Sanskrit. Thus, they reached the common man. But after the Aryabhata's advent, we don't know what happened to Jain astronomy and mathematics. Not much significant contributions are available to us for various historical reasons. So this Ashmaka is believed to refer to a part of Kerala according to some scholars, mainly because Aryabhata's text is popular, its procedures are popular in Kerala region. But that does not seem to be very much true. To identify the Ashmaka region, we have to go back to history of Aryabhata's time. And in Varamira's Brad Samhita, there are geographical references to various regions. And according to him, Ashmaka refers to some part of northwestern region. Maybe this present Rajasthan, then Saurashtra, etc. In that region, and even Bhaskara I, who popularized Aryabhata, belonged to that region. So personally, I believe by Ashmaka is meant that region, northwestern part of India, rather than Kerala. Though it is a fact that Kerala's contribution to Aryabhatan system is really very significant. Then there is a text about, apart from Aryabhata Bhashya, he has Mahabhaskariyam and Laghu Bhaskariyam. These two are complete texts which are rather elementary and explain beautifully the procedures of Aryabhata. And what is significant contribution is, coming to mathematics, the so-called Diophantine equations are explained very well in Mahabhaskariya, and he gives beautiful examples from astronomy for the solutions of Diophantine equations. Well, Diophantus was a Greek mathematician, and that name for the equation is wrongly given. The Diophantus himself did not significantly contribute anything. The credit of giving the general solution of a first order indeterminate equation, I will come to that point, comes to Aryabhatta. Aryabhatta in his text explains in detail how a first order indeterminate equation can be solved. An equation of the type ax plus by equals c, where a, b, c are positive integers. X and y are two unknowns, and you have to solve that equation for x and y in terms of integers. Note that there are two unknowns and a single equation is given. That's why it will have infinitely many solutions. And Aryabhatta tells us how to generate all those infinite solutions of such an equation. And by the way of application of this solution of indeterminate equation, Bhaskara 1 gives some beautiful examples. We may not have occasion to refer in detail to those examples. Some of the important Saka.
ಅಂದ್ರೆ ನೀವು ಇದನ್ನ ರಿಪೀಟ್ ಮಾಡಲ್ವಾ ಸರ್ ಮಂಡೆ? ಯಾಕಂದ್ರೆ ಈಗ ನಮ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ನವ್ರು ಮಾತ್ರ ಇದ್ದಾರೆ ಆಡಿಯನ್ಸ್ ಅಂತ.